everyone, so welcome to lecture number 2 of types of relations. In the previous lecture we started the topic that is relations and functions. Just a quick review what we have studied last. We have gone through the what is the meaning of relation, right? What is the meaning of relation? We have gone through the what is the meaning of set, then what is Cartesian product, relation means, what is the meaning of function, and the very important term for MCQ purpose, every function is a relation, but every relation is not a function. These are the two true statements. So statements can be given and the question can be asked, right? So I hope it is clear to you. You can again re-watch the lecture number 1, but the lecture number 2 will start with the what are different types of relations, and then we'll solve some of the questions. Again, I'm saying that whenever we are discussing theory, in theory you may feel it a bit confusing, but when we'll come to the question part, then it will become easy to you, or you will understand what is the meaning of each and every function or relation we are going through. So let's start with, now the relations we have discussed in the previous lecture. Now we are coming to the what are different types of relations, right? There are different types of relations, but the very first relation is empty relation. What is the meaning of empty relation? Okay, so if we talk about empty relation, as the name itself indicate that no connection between any elements, that is the meaning of empty. Empty means which does not contain any element, or in other words, it contains elements but it does not have any relation with that particular set that we are discussing, right? That means in an empty relation, no element is related to any other element, right? For example, start with this example. Let us say there is a set that is A which contain following objects. I hope you remember 1, 2, 3, 4. These are known as objects or elements. So if there is a set A and it contains these elements 1, 2, 3 and 4, and we have some relation R in which A comma B with a condition, this sign represents condition A minus B is equal to 10. What is the meaning of this? It means A minus B, that if we are selecting this set A, so if we are selecting any two numbers, this relation will only exist when the difference of the sum, difference of two numbers will be equal to 10. That means A minus B should be equal to 10, then only this relation exists. So if you are taking two numbers, let us say you are taking 1 or 2, so 1 minus 2 is equal to minus 1. It is not 10. The condition is that we should select any two objects or elements whose difference is 10. So in 1 to 4 there is no element which have difference equal to 10. Highest difference can be 1 minus 4, that is 3. So the relation is not related to the set. No two numbers in A have a difference of 10, so no pair is formed. So such type of relation is known as an empty relation, right? Relation is this, but whatever relation is coming, it does not contain elements in the set A. So such type of relations are known as empty relation. Kindly understand the meaning of empty relation, right? Okay. Now next type of relation, this is the type of first type. Then the second type of relation is the universal relation. It is just opposite of empty relation. Empty relation means no element is related, and in universal relation each and every element is related to other element, right? So again, coming to the example, you just remember the definition. Meaning of universal relation: every element is related to the every element, right? How? Let us see the example. A is 1, 2 and 3. The relation that we have here, it is A comma B. That means with the condition A minus B, difference of any two should be either greater than 0 or either this sign represent equal to sign. So either it is greater than 0 or equal to 0. So it is obviously 1 minus 2, 1 minus 2, because this is the here it is written between the absolute brackets. These are known as absolute brackets. Absolute bracket means whatever value is coming, it will always be positive. For example, minus 1 is there. absolute brackets are there, it will be equal to 1, right? So this condition, that is relation a comma b, a minus b is greater than 0, it is true because difference of any two numbers in the set A will be always either equal to 0 or greater than 0 because we have the absolute brackets here, right? Next third type of relation is reflexive. Very important points. From now onward you check the, because in imperative relation or the universal relation they are just for MCQ parts, you just need to remember their definition, but when we are coming to these types of next relations you must remember them and try to understand what is the meaning, so that will solve the questions, right? So reflexive relation means every element is related to itself. Firstly, understand the definition. What exactly is the definition? Reflexive relations, those relations in which every element is related to itself. For example, for any set A relation R on A is reflexive if A comma A belongs to R. Now I think there is, let me first explain what is the meaning. Let us say there is a set 1, 2, or let me first write the set because it will be in curly bracket 1, 2, 3, 4. Understand what is the meaning. Now if I am writing its Cartesian product, it means it will be first 1, 2, right? 1, 3, 1, 4, right? Then 2, 1. I forgot one here. Let me just write it here only. 1, 1, 1, right? So again, next is 2, 1, 2, 2, right? 2, 3, 2, 4, then 3, 1, 3, 2, 3, 3, right? 3, 4, then 4, 1, 4, 2, then 4, 3, and 4, 4. These are Cartesian. Now if I'm talking about the relation is means I'm selecting any elements from it. For example, I'm selecting 1, 2, right? 1, 1, 2, 2, 3, 3, 4, 4. I do not require selection of all the ordered pairs. I can select any 4 just to define the relation, right? So relation means, what exactly is the meaning of relation? Now coming to the definition, for any set A relation on A is reflexive if A comma A belongs to R for every A belongs to A. What is the meaning of this? This might be confusing, right? Now this relation is known as the reflexive if it contain A comma A, these elements are the part of this relation. What is the meaning here? Again, let me explain here. You have 1, 2, 3, and 4. This relation R will be reflexive if this relation contain following points: 1, 1, right? 2, 2, 3, 3, 4, 4. That means element itself, AA, 1, 1, 2, 2, 3, 3, 4, 4. So if the relation contain at least these elements, then such relation is known as a reflexive relation. A reflexive relation. So set contain 1, 2, it contain 1, 1, 2, 2, 3, 3, 4, 4. So these set contain these elements. So such elements or such relation are known as a reflexive relation. Try to understand, rewind the video, you can easily understand. For any set A, let me read this definition again. A is relation R on A is reflexive if A comma A. A comma A, again what I mean is you select any element from A, let us say 2. So the relation will be reflexive if it contain 2, 2 also. So 2, 2 is here. So this relation is reflexive, right? Why it is reflexive? Because the difference of any two number with itself is 0. It is understood, right? Now I'll not go with the example because when we'll be solving the question, you will understand. But for now, reflexive relation means if the relation contains every element, the relation R on A is reflexive if A comma A belongs to R. So I hope it is clear to what I mean to say here, that this is the set A. So this relation will be reflexive if it contains each A comma A. Each elements belongs to. Next is symmetric relation. What is the meaning of symmetric relation? If A is related to B, then B is related to A. Let me write here. This is the set 1, 2, right? So again, as I said, the relation will be the A comma A, that is Cartesian product. It is 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, 2, 3, then 3, 1, 3, 2, and 3, these are the all Cartesian products, right? So relation, as I said, these are only selective pairs, right? So selective pairs means, let us say I'm selecting 1, 1, I'm selecting 1, 2, I'm selecting 2, 1, I'm selecting let us say 2, 3, and so on, right? So relation is this much only. That means selected pairs. Now, if A is related to B, then B is also related to A. So any relation is known as symmetric. This relation will be symmetric if it contain 1, 2, if it is there, 2, 1 should also be there. If this is A, this is B, so B, A should also be there in the relation. Then only such relation is known as symmetric relation, right? Such relation is known as symmetric relation, right? So for any set A, relation R on A is symmetric if whenever A belongs to R, then B comma A should also belong to the R. These are MCQ questions. You will face this type of questions, like if any set is said to be symmetric, if it contain AB, then it must contain BA also. That relation is known as the symmetric, right? So last type of relation that we need to understand before going to the examples is transitive relation. Transitive relation means if A is related to B and B is related to C. Understand this definition. If A is related to B, B is related to A, right? Or sorry, if A is related to B, B is related to C, then A must be related to C. That is the definition, right? If we have three sets, let us say there is a set and we have A, B, and C. So relation will be transitive if A belongs to B, if set contain A comma B, B belongs to C, right? Like A belongs to B, B belongs to C, then there should also be A belongs to C. This condition should also be full. Then only such set is known as transitive, right? A belongs to B, B belongs to C, then C must belongs to A, right? A belongs to B, B belongs to C, then there must be relation between A to. It will come to you in the example, so that is why I'm just going through the definition. Last part of the relation is what is an equivalence relation. If the question is prove that some set is the equivalent set, it is only possible equivalence relation means relation which is reflexive, which contain same element also, right? If it is symmetric, that means A belongs to B, then B must belongs to A, right? Or it is transitive. Transitive means if A belongs to B, right, B belongs to C, then A must belongs to, right? These are the basic definition. Or again, let me write here what I mean to say here. If the question is prove that this set is the equivalent set, it is only possible when we have reflexive, means the relation must contain the number and its reflexive point also. Symmetric, if it contain a comma b, then relation must contain b comma a also. Transitive, if it contain a comma b, b comma c, then it must contain a comma c also, a comma c also, right? So if these three conditions are fulfilled, then such set is known as equivalence set. Such set is known as equivalence, right? Equivalence. Now coming to the example. Very first example that is given in your NCERT book is, let P be the, try to understand the question first. P be the set of all triangles in a plane. Define a relation R in T as R is equal to T1 comma T2. T1 is congruent to T2, and show that R is an equivalence relation. Very important point. Now the question is, let T be the set of all triangles in a plane. There are multiple triangles, you don't know, T1, T2, T3, T4, like it is written here, because question is set of all triangles. So set of all triangles means there are multiple triangles, T1, T2, T3, T4 and so on. Now the question is, the relation means any two sets has been selected, right? But the condition is T1 is congruent to T2. That means two triangles are congruent to each other. Now if in simple language, congruent means which can overlap each other. And what can overlap each other? The triangle itself, or the triangle are of same shape and size. Such triangles can overlap each other, and these triangles are known as congruent triangle, right? So congruent triangle here means, congruent triangles means, I'll write here congruent triangle, right? Congruent triangle means the triangles which are of same size and shape, right? If for example this angle is triangle is T1 is like this, and if I'm saying that there is another triangle T2 which is congruent to this T2, it means this angle triangle T2 will be also of same shape and size like it is T1. So whenever I'm placing T2 over T1, it both will overlap each other, right? Now coming to question, if T1 comma T2, T1 is congruent to T2, then R is an equivalence section relation. So equivalence means we have to prove that triangle is reflexive, it is symmetric, and this relation is a transitive also. Now reflexive means if every triangle is congruent to itself, T1 is equal to T1, right? So it means T1 comma T1 belongs to, this relation will exist in the R because these are congruent also. So T1 comma T1, this relation will always belong to the relation that is given to us. Next part, symmetric. If T1 is congruent to T2, then T2 is congruent to T1. It is common, right? So remember this situation I told you, the reflexive means if A comma A, if A comma A are belonging to the relation, then such that relations are known as reflexive, right? In the question it is given that both the triangle are reflexive to congruent to each other, right? Congruent to each other. It means T1 is congruent to this T1 only. So that means T1 comma T1 belongs to relation that is given to you, that is R, right? So this condition is fulfilled. So the very first, the given relation is the reflex. Second part, that whether it is symmetric. Symmetric, what is the condition of symmetric? A comma B, if it is given in the relation, B comma A should also be the relation. What is the meaning of A comma B here? A comma B means T1 is congruent to T2. So if T1 is congruent to T2, then T2 is also congruent to T1. That means if T1 can overlap T2, so it is obviously means that T2 can also overlap T1. So if T1 comma T2 is belonging to relation R, so it is automatically understood T2 comma T1 will also belong to relation R. So that is the condition here. That means the given relation is symmetric also. It is symmetric also. So second condition is also proved. Next is transitive. Transitive means, what is the condition of transitive? Check here, what is the condition of transitive here? That if it contain following relations, right? If relation contain A comma B, B comma C, then A comma C should also be there. Here what is A? A is T1, B is T2 and C is T3. Question given is the triangles are overlapping each other. So if T1 is overlapping T2, T2 is overlapping T3, it is automatically understood that T1 is also overlapping the T3. So this condition, that is T1 comma T2 belonging to the relation R, T2 comma T1 T3 is also belonging to relation R. So hence we can say that T1 is also comma T3 are also belonging to relation R. So the condition of transitive, that is if T1 is congruent to T2, T2 is congruent to T3, then T1 is also congruent to T3. So such relation is a transitive relation. Hence we have proved that the relation are reflexive, symmetric and transitive. So when these three conditions are met, since R is reflexive, symmetric and transitive, therefore R is an equivalence relation on the set T of all triangles in the. Now you might find it a bit confusing, and because the angles are there and you are finding it where it is A, where it is B, give it some rewind the video again, you will come to understand what is the meaning of the relation here. A comma B or A, B, C, and here I am writing T1, T2, they are nothing but the nomenclature only. This A comma B I have written here, it is A, just a representation, because in the coming questions we will have numbers also. Then I will not write AB here, I will write, like for example, let us say I have number A in terms of 1, then B I have 2 and C I have 3. So I will be using these numbers. Then that is just to show you the formula. So for now I'll stop here because so much discussion has been done. We'll continue remaining 2 questions and the revision of the exercise in the third lecture. But for now I'll stop here because it is a bit confusing. You might find it is easy. You watch this video one more time, you'll come to understand that these are easy questions, right? So I'll stop here. Thank you very much and stay safe.